First and foremost, welcome to Space Data Hackers. This is our first ever meeting. This is our kickoff for what I hope is going to be a really great component in the fantastic ecosystem for data, technology, and space in Seattle. And we'll talk a little bit about what that means to us and what I hope it'll mean to you all. Okay, advancing the slides. So agenda for tonight, we're gonna start off with some introductions of myself and James and Sean. We're the board of directors of the Space App Seattle Foundation. And we decided to put together this meetup for a variety of reasons. So we're going to also introduce the meetup and you know, kind of what the vision is and where it came from. We're going to have a speaker tonight. Pranab from the University of Washington is going to be talking to us about what he does with space data, but and also just kind of like a backgrounder for you know, kind of an introduction to NASA data sets and how to use them. And then we're going to spend some time connecting. I'm really excited for all of you guys who came out and are showing your enthusiasm for space and data. And I hope that we can learn more about each other, you know, stimulate ideas of, you know, the kinds of activities and speakers and the kind of learning that we want to do, the kind of connecting both with this community and other communities, and the kind of doing, right? And we'll get into a little bit of that further on. Okay, so me, there's a bunch of folks who already know me. I'm Michael Doyle. I am co-organizer for Space App Seattle. That is the local event of the NASA's International Space Apps Challenge Hackathon. I know there's a bunch of folks who are on the call who've been through the hackathon or know what it is. I'll talk a little bit more about space apps and what it does globally and how we've evolved it locally. And one part of that evolution is that this year, 2021, we founded the Space App Seattle Foundation, a nonprofit, to put on this hackathon event that happens every year in October, but also to further the use of space data within the Seattle community and really beyond. I will hand it over to my co-organizers to introduce themselves. James.
Yeah. Yes, so this is James Burke. I am the IT director at the Mars Society. I run our Seattle chapter. And last year I started helping Michael with the Space Apps Seattle event, part of the NASA Space Apps Challenge. This year it will be October 2nd and 3rd. It's always a weekend, it's a hackathon. We're really excited about that. And as Michael mentioned, one of the reasons why we wanted to start this series is to lead into that. And we have some other ideas as well, I'm sure we'll share with you in the future. So welcome everyone.
Sean.
Yes. Hey, everybody. As you can tell, I'm in the car. It's a nice day, and I'm in between events, but this is one I absolutely wanted to prioritize. It's been a great pleasure to work with my good friends James and Mike on this. I founded the Space Entrepreneurs Network in February of 2014. Was born and raised in Seattle, and you know, in looking for a more meaningful career path, found space, and, you know, just found everybody, you know, to be, no pun intended, but really down to earth. And, you know, getting to work with James and getting to work with Mike, not only on this, creating this meetup, but on, you know, some of the events that Mike mentioned, Startup Weekend, Space Apps. I think what we're trying to do is continue to cultivate a community of people who are passionate about space. And, when you talk about Seattle and its history in aerospace, and when you talk about the IT ecosystem and the aviation ecosystems, what more exciting than to work on space data, whether that's imagery or doing things with the imagery, or there's just so many applications, to help make life better on Earth, and then to help, our activities in space. So again, it's very exciting to be here, and it looks like we've got a great crowd of familiar faces and new faces. And for those who are new, welcome to the Seattle space industry community and space data community, and just excited to be a part going forward.
Awesome. Okay, so I want to talk about space apps. This is going to be familiar to some of you, but maybe new to others. And what is it? It's NASA's International Space Apps Challenge. It's the world's largest hackathon. It's been going on since 2012, and it's grown pretty much every year. We've been having it in Seattle since 2015. I participated as a hacker in 2017 in Seattle. I hacked in New York, which is where I lived previously, for 2 years prior to that. For the 2018 season, I put my hand up to organize, and we started taking it in a new direction. And I think we've had a really great experience bringing the technology community that exists in Seattle and the space community together as part of the event. And the purpose of the hackathon is to take on challenges that NASA puts out that are about improving life on Earth and furthering our future in space. And it all takes place over a weekend. People come together on a Friday evening with either people that they know, or maybe they'll meet people on site, and they'll form up teams. And the teams pick a challenge, think about what they want to do with that challenge, access NASA data sets, be creative, create applications that might be websites, might be mobile apps, might be virtual reality, might be something like physical, concrete, models and things like that. And they hack that all weekend long, and then they come and they present on Sunday evening before a panel of expert judges. There's local awards that are awarded by us in Seattle, and we pick 2 teams to go to global. Global teams are teams that go to the global judging round, go into a pool of over 3,000 projects typically in a given year. We've been fortunate that we've had some projects from Seattle advance to the global judging rounds and get to the finals, which is pretty amazing. The wonderful thing about Space Apps is that it intentionally seeks diversity. It looks to bring in a wide array of talent and people with diverse skill sets, because when you're trying to solve a problem, that's what you need. And the problems that Space Apps aims to solve are big problems. They are things that are related to global warming, to forest fires, to living on Mars, to going to the moon, to educating the world about space and about science. And I can tell you, as a person who went into Space Apps in 2015, and it was my first hackathon, it can be a life-changing experience. It is, you will hear people again and again talk about what a great time that they had hacking, and how they bonded with their teammates. They did something interesting and amazing, and you know, they got recognition, and the awards that they earned, or just the experience of going through and learning something new, trying something that they never knew was possible. Like, I didn't know that I could be working on something that NASA is thinking about on a given weekend. So, you know, we started to get to thinking, James and Sean and I, and, you know, Michael Patrick, who's with us tonight, was on that virtual edition of Space Apps back in October. What could we do more? You know, we have a lot of people coming into Space Apps who have no background, no familiarity with NASA data. We have mentors on site who can kind of guide them and help them. But wouldn't it be great if they could, if they could come in with a little bit more knowledge, a little bit more preparation? And then after the hackathon, what happens to that project? What happens to those teams? Some teams do go on to do something else. Maybe some teams go on to do other hackathons. But there are wonderful projects that I've seen in that come out of the hackathon that you know, don't really go all that far. Well, what if there was a way that you could keep teams together, keep them working, and take the projects to the next level, whether that's, you know, further development in the open source community, or creating a startup around them, or a nonprofit. There's so many possibilities if there's a little bit more stickiness. And, you know, the possibilities that Seattle specifically offers to people who want to pursue this are just amazing. There's an amazing range of resources and talent here. You know, from the cloud computing and data science expertise that and software engineering expertise that's abundant in Seattle, to the space expertise, right? And the legacy of you know, space exploration and development that's in Seattle, that is continuing to grow, but exists in somewhat of a separate community. How do we bring them together and then make the most of them? You know, if you want to know about a certain set of data that you can use to have an impact that you're thinking about, well, there ought to be a community that can help you with that. And if there's no space-based data that is publicly available, well, maybe there's private ones, or maybe there isn't any. Maybe, you know, you've got your idea for a satellite or a package of sensors, you know, that ought to go up on a mission, right? Seattle has the full range of capabilities to be exploited and brought together. The people and institutions are here. And that is something that made me think about how we can make the impact of projects that are happening in the hackathon even bigger. But I also want to make sure that, you know, as I'm painting this vision of space data hackers as the way that we get there, it's not just about the hackathon, right? It's about bringing anybody who is interested in being a part of this, who has an interest in space data, who can mentor others, who can, you know, who wants to learn, who wants to be creative with data, but maybe needs technical expertise, or maybe needs storytelling expertise, to bring it all together so that we can create projects, we can create learning, we can, you know, build the connections that I was talking about, spur entrepreneurship, build STEM skills amongst folks that might not otherwise have an inclination or an opportunity to do that. And so that's what's in my head, as I've been thinking about, what this meetup could help solve, a piece of the puzzle that can fill in and spur some of this activity, and just give us all a place where we can express our love of space, our love of data, and do great things. And it starts with you. James, did you have anything that you wanted to add on these slides?
So I think you've really captured it well, Michael, the vision that we have. And I have a personal belief that in the next 10 to 15 years, there's going to be a lot of new companies that are started in the space field. As you all, I'm sure, are familiar with, there's a lot of development happening right now with rocket technology. And Elon Musk is right out in front of that with his Starship. But locally, we have Blue Origin and several other companies working on it. What's going to happen, I think, pretty soon is there's going to be more capacity for rockets and launching things up into orbit, and also launching things around the moon and on the lunar surface and off to Mars. And there's a lot of companies that are going to get started to utilize that capacity. And so what I would love to see, and I think Michael and Sean would agree with me fully on this, is I'd like to see Seattle capture some of that, those companies, help develop some of those companies here locally. And so that's one of the reasons why we wanted to start this meetup series, is to help develop the talent that's going to work at those companies. I have a personal interest in data. I'm a tech guy. I used to work at Microsoft. I'd love to see what people can do with space-related data sets. I'd love to help them however I can to pursue that that interest. And this meetup series and the Space Apps Hackathon are I think the two best ways I can do that. So I'm really proud to be part of this and looking forward to this being a great series.
Awesome. So the format that we've been thinking of, and that we're kind of piloting tonight, is learning, connecting, doing, right? And for the learn part tonight, we've got Pranab connecting. We're going to be doing that a little bit later. The doing is going to come out of the connecting, and doing can simply be nerding out over space-based data. That's perfectly fine. We do plan to have the meetup on the last Thursday of every month, and make sure that we've got speakers and mentors to keep it interesting. Open hack nights is another thing. Some of our sessions maybe just come together with your project and show it off, or get others to join in. I think some of the folks who signed up for this meetup are also on the Puppy, the Puget Sound programming Python meetup, and that was something that was a little bit of an inspiration for me too. I really loved that community where you had rank beginners and software engineers in the same room, kind of connecting with each other at all different skill levels, and sharing and doing things that were interesting to them. And as we get closer to the hackathon, I'd like to introduce a few more additional sessions, so that we can start funneling some of the folks who come to the hackathon, who sign up for the hackathon, into sessions that are specifically maybe a little bit more targeted, maybe a little bit more boot camp like, to prepare for the hackathon. We tend to get quite a few folks signing up. Since we have a virtual format, we can this year we can accommodate a whole bunch, and kind of let it be a cycle of learning, connecting, and doing, right? The whole idea behind this meetup series is that it shouldn't be just once a year. You do the hackathon and that's it. There should be a place that we can go and continue to connect and continue to learn. Okay. So I am going to hand it over to Pranab K. Roy Chowdhury. Forgive me, Pranab, for mispronunciation. He's at the School of Environmental Forest Sciences at the University of Washington, and is going to give us our introduction to space data.
All right, excellent. Thank you so much, Michael, for the introduction. Thank you for the opportunity to be here. As Michael already said, sorry, it will take a few seconds for the presentation to load up. Yep, there we are. So I got involved with the Space Data Hackathon back in 2019. Actually, that was the year also I moved into Seattle. And it's been as Mike was saying, it was a great opportunity to be there, help it out as a data mentor. But I learned so much, there was just so many new ideas there, and I can't wait to participate this year. So so my talk, and I was hearing the initial conversation. I know, like James, Mike, a lot of other folks probably are more interested, are very much interested in planetary remote sensing. Apologies in advance that my talk will mostly be focused on terrestrial remote sensing, because that's where my work is concentrated. And at any point of time, feel free to just unmute yourself, ask a question. I would really love this to be interactive. So as Mike said, my name is Pranab Chowdhury. I'm a postdoctoral scholar at the School of Environment and Forest Sciences. And so what are the Earth observation datasets? So NASA, and we're talking about NASA. So NASA makes available from their research, and it's their mandate to make everything available to public. And they not only make these satellite images available, but they also give you derived data sets, tables, which are basically extracted from those satellite data. Then they also make available codes, APIs, documentation, data catalogs, and of course, external data sets that from other agencies and publications, which are very helpful to understand their work. So, NASA makes, if you go through, and I'm going to show you some of the websites, you can access their satellite images, satellite image derived data sets, which are really useful a lot of times, because, they're doing the preliminary work, like initial, raw satellite data set need a lot of pre-processing. So they're doing it and then giving a derived data set. There are tables, codes, APIs, documentation. These are all available for people to use, and for whichever their area of interest is. And the advantage is it's a huge collection. The last time I checked it, there were 43,000 data sets and around 550 code repos, and I'm pretty sure it's a year-old stat, so it has grown a lot by now. And most of them are documented, and that's a huge relief when you're using with the different kind of data sets. And we really need to use these data sets. And as I said, I'm going to talk only about terrestrial stuff. So for me, sustainability, food and energy security, poverty alleviation, those are things that are really close to me, and I use these data sets to be able to answer those questions. And the best part is it's all free of cost. These are some of the portals that you can use. Like, I'm not going to just read the names, but they're self-evident. But if you look at it, it's not only nasa.gov, but there is also Columbia, like within Columbia University, there's a CSUN, and they are very well known for socioeconomic analysis. So a lot of NASA data, they actually, they do make the derived products, and then they make those available, especially for population, socioeconomic data sets. They're a really great website. And mostly, if you go and you try to use one of these get data, download and access gateways, they will look like this. On the left-hand side, you'll have all this probably already know, but you can go through, if you know what data you need, but you can also do a spatial search. Like, if you look at on the right-hand side, there are these tools, you can draw a polygon and then do a search, which basically tells you what data sets are available for that region. You can do, as some of you may know, that if there is a lot of cloud cover, that satellite data is kind of not really usable for any science application. So you can do those sorting. You can put a threshold. Okay, anything has more than 10% cloud cover, I don't want to see that data. This is a really useful tool, and the Earth data, I think, has recently been kind of revamped. It's very awesome. But alongside NASA, there are other agencies as well. They're making these data sets available. There is ESA, there is JAXA, Indian Space Research Organization. There is NOAA. NOAA is I have used a lot of NOAA data sets throughout my career, and fantastic data sets you can get from them. And there are these newer, commercial companies that are coming into play, like Digital Globe, now known as Maxar. There's Planet Labs. There is Hexagon Geospatial. But these are commercial data sets, so to be able to use them, it's generally paid, or sometimes institutional agreements. Depends on the situation. And this is a non-exhaustive list. It just, as James was saying, new companies are coming in, and this, the satellite data providers are growing exponentially. So I just wanted to, and I'm pretty sure a lot of you already do that. So I don't know, but how useful it would be. But some of the tools that we all use is, for EO data processing. First is Python. I know you guys are talking about in some Python meetup groups. So some of the libraries that people use that I've seen is, GDAL, OGR, and then GeoPandas, Rastrio. These are then rasterstats. These are excellent. I'm at NumPy. You can never go around NumPy. So these are excellent libraries that enables us to handle satellite data. But having said that, sometimes, as I was saying, you need to do some preliminary pre-processing, like atmospheric correction and all that stuff. Then you definitely need to use specific libraries that is made for that data. And those are, in some cases, available, or the satellite data provider gives you a tool to work with it. Similarly, on R, there are a bunch of, counterparts available to do the same thing. Now, there's this website called OSGeo, which is open source. I don't remember the rest, but they have a suite of tools. They have desktop softwares. They have this libraries, plugins that you can play with, and it really makes life a lot easier. It's basically a foundation. And then there's Google Earth Engine. And what I'm seeing in scientific work, more and more people are using Google Earth Engine and moving away from desktop architecture. And what the best thing is collaboration. The codes are available. You can collaborate on runtime rather than having it in silos on our own computers. But as I said, desktop, but there are a few things that desktop programs are still doing. And so ArcGIS, it's a paid one, is the only commercial software that I'm going to talk about. And it's been a workhorse. I know Michael Patrick was talking about GIS. So in many ways, ArcGIS has been, the whole idea of GIS was kind of built around ArcGIS for a very long time. Then there are open source counterparts like QGIS, which is very useful nowadays. I mostly try to use QGIS, sometimes ArcGIS, depending on the problem and their capabilities. Then there's GrassGIS, which is good, and they're very good in certain kind of data processing. There is SagaGIS, Pulsar Pro. It comes from ESA. It's a very good, it's a very efficient tool to process synthetic aperture radar datasets, if anyone wants to use that. Then there's GVGIS, but I'm not very familiar with it. And once we process data, but why are we doing it, and the application areas. And there are, these are, again, it's a list that I just put up, but I'm pretty sure there are other areas that people are using it for. But basic and applied research, and I have this, I don't know, but I think it's being recorded, so you can get those names later. They have really good lists of examples of what these datasets are using. But I've seen basic and applied research. There's Earth system monitoring, and NASA is really a pioneer in that. And there's socioeconomic research, as I said, CSUN in Columbia. But I know NOAA has a group. It was in NOAA, but it's moved to Colorado School of Mines now. They're another very active group in socioeconomic research. Then there is simulation and forecast with GSFC. NASA does a lot. Then you can also do like purpose-built data catalogs, and those are useful for end user. Sometimes nobody, I mean, like finding data is in itself. I know a lot of professors actually put this module in their courses, in GIS courses, like how do you go and actually find the data? How do you bring it into your workflow and actually start to make sense of it? So custom built data catalogs are really helpful. And then you can have apps to ingest daily produced data sets. But and as we're talking about commercial application, and this is a place that is there's an area that really getting a lot of momentum nowadays. So what the few that I've seen is crop yield and monitoring and prediction. They're doing forest carbon mapping using LiDAR and hyperspectral, even optical data sets. Then deforestation detection, building and road detection, monitoring of like even like AWS sort of monitoring, like ship monitoring or any kind of vessel or airplane, whatever, asset monitoring basically. Then there is risk and vulnerability assessment, and of course there is on-demand imaging, which is Digital Globe does, Planet does a lot, and Planet has those sort of microsatellites, which is they're very good at it. But I know Descartes Lab, the second one, the URL that I've put in, they are very, very well known for crop yield and monitoring and prediction, forest carbon mapping. And if you go to their website, they have kind of like description about what they're doing. Hexagon Geospatial is another company who are active in this. I know Planet also is doing some research. Then another use, and that's mostly still done by the government or a research organization. So this dashboards, which is another really good example of how we can build some meaningful use of space data. So this is from the first one on the left side is an air quality, but it's basically NASA worldview screenshot, but you can have multiple layers. I just took the air quality one, but there are multiple users just similar to the Earth data. Go to the left pane and try to see which layer do you want to see, and then they'll just pull that data for you. On the bottom right, it's the Pacific Disaster Center's disaster warning system, and it's called Disaster Alert. And if you see, they pull it from multiple sources, and it's not only spaceborne or Earth observation data, but they have there's data coming from like multiple different sources. These are all remotely sensed data in pure sense. Like you have seismic sensors, you have it's a huge list of input data that they're taking, but so it's basically building on top of the remotely sensed Earth observation data, but then you have other sensors that are building on top of it, just to give people a real-time disaster alert mechanism to react to. So that's kind of like my really fast, what those data sets are, how you can, what you can use to process them, and how you can use. I thought I would take a little bit of time to also say, what do I do? And, so I am a geographer and a computational social scientist by training, and I've been using remote sensing data since 2008. And so I started as, I was doing a master's in remote sensing and GIS applications and urban and regional planning from Indian Space Research Organization. And that's how I started. And I've seen the shift from, coarse resolution to really high resolution data sets now that you can even probably read a car's number plate if you really want to. And also I saw the shift from satellite-based remote sensing to airborne platform, which are faster, like drone and all these things coming in. But most of my work, and I think the focus for me has always been urban and environment sustainability. And personally, my goal always has been to try and find ways to make our future on Earth more sustainable. So most recent work is in the area of assessing the efficacy of forest management practices here in Pacific Northwest and the role of policy measures in sustaining the ecosystem services that we get from these forests. I also work actively in land use and land cover change mapping, identifying their drivers and their impacts on our sustainability, and social impact of climate change mitigation efforts. Like we a lot of time talk about, yeah, we're going to do this, we're going to put in this land-based measures, but we also have to understand there is this that there is always a social cost of implementing any land-based policy or any change in the existing practices, and somebody has to pick up the tab. So we also try to understand, like, where it is more efficient, because we have a suite of ways to do things, but then not everything is suitable for every region. And I'm a geographer. For me, space matters. Do I also look at that? So if you look at the top right graph, it's actually from, if anybody is familiar with agent-based modeling, one of the things that I do, it basically, rather than purely observational analysis, it goes more into, it uses observational analysis, but it also goes more into mechanistic modeling of human behavior. And we as humans, our behavior, we adapt, right? And like price of a commodity changes, and I buy more or less of that depending on how I value that and how much money am I willing to spend. So we bring in those heterogeneities in human behavior, and also acknowledge the fact that not every human is the same. Price changes, somebody might buy more, somebody might buy less. So to bring in all those heterogeneities, and this basically shows that if you look at the orange line, the baseline forest management practices, and this is from a study area that size is around 400 square kilometers north of Forks in Olympic Peninsula, that the forest carbon is kind of like, it's not growing, it's just staying static where it is. But if we really need to, because first of all, why do you even care about it? Sorry, I skipped over that. It's a sink, right? It's a sink where we can actually store the carbon from, get the carbon out of atmosphere, which is so important for our survival and fighting climate change. So the green line and the blue line are policy interventions. The blue line is a market-based intervention called carbon rent, and the green line is a institutional intervention where we let the small landowners cooperate and bigger projects, so that they can also compete into carbon markets competitively. So if you can actually see, when we let that happen, when we reach around year 2080, we actually see there's even more carbon to be sequestered in the forest if we let those flexibilities built into the system. It's a paper that I'm finishing right now. And the bottom one, we just, our school, a lot of us, I was a part of it. We just got together. We did a lot of in-depth analysis of the small forest landowners. We were asked by the state, and this report is public. If anybody wants, they can go to DNR website and download that. So I really wanted to talk but I know I don't want to talk about modeling, but just talking about remote sensing. I think I'm doing good on time, Mike. Yep.
Yeah, you're doing great.
Okay, good. So this is one of the studies that purely uses Earth observation data and processing to gather insight. I did that when I was a PhD student. I also got my fellowship through Oak Ridge National Lab, that's in Tennessee. So what the point was, the electricity is, if you look at the data, it's the fastest growing energy sector by source. But the problem is, we do not really have electricity usage data at local scale, or even for regional scales. So we really want to say at Oak Ridge, what they do a lot of building detection at very high resolution. And at that time, we also started to realize that human interaction, that the socioeconomic status also has a telltale sign on where we live, right? Think about an informal settlement versus a downtown versus, really those affluent neighborhood where the roads are wide and the houses are really well laid out, versus rural areas. So what we wanted to see, that we had access to this really high resolution optical data set, like ranging from 0.3 to 0.5 meter in spatial resolution. We wanted to see, what can we infer about urban energy consumption at local scales? So we picked 3 different cities. One was Ndola in Zambia, and in the global map, the countries are marked in green. Then Johannesburg in South Africa, and Sana'a in Yemen. And together, these 3 cities kind of cover, they're home to 14 million people. And as I said, there is no ground statistics for energy usage. So what we did was, there's a satellite called VEERS, and it's a program. Sorry, I cannot remember the whole name right now, but they have one of their band is called day-night band. And what it basically does is, at nighttime, it captures optical part. So when you're doing remote sensing, you're basically trying to, in the whole electromagnetic spectrum, your sensors are basically picking out a window, and within that window, you're basically measuring whatever energy is coming in, right? That's the fundamental. So what this one does is it picks out the optical part and also near infrared, which is very useful when there is no cloud cover or lunar illumination. You're basically picking out lights that are coming out from human, human presence. Of course, there are artifacts like gas flares and biomass burning. And this is the group that I was mentioning that they were used to be from NOAA. Now they moved to Colorado School of Mines. But they still do this, and they do a fantastic job of, and I've been working with them for like since 2008 actually when I started. So they have these algorithms to take care of the gas flares and biomass burning. So all those errors that could throw our numbers off, those are generally taken care of. So what we did was we used this high resolution optical data to classify this urban areas into what we call functional neighborhoods. And I'm not going into much, all this, you can read if you want, but basically class 1 was informal settlements. And if you go at the top row of the figure given, so those are a manifestation of them in those 3 cities. Class 2 is what I'd call more affluent neighborhoods. Sorry, class 2 was sort of high density urban housing and suburban. Class 3 is what the more affluent neighborhoods. If you look at Sana, it's very evident, or even in case of Johannesburg. Class 4 is mostly industrial or downtown commercial entities. And class 5 is rural and anything that was not captured by the other 4 classes. So what we did was, so this is kind of like a visual representation of what we did. We first found out, we did a building detection. We found out where the building footprints were. Then we classified it. And okay, how we classified it, I should also mention that. So we used something called texture analysis, part of computer vision. And we used 2 different filters, one called Gabor and one called Laplacian of Gaussian. And these are all linear filters. And they basically try to detect the edges. And we use like 6 different specifications of those. And then we basically overlay that on top of, this is the night, the C is the nighttime lights. That's how a VIIRS DNB data looks like. Those are the lights coming out of the city of Johannesburg, and then we overlap that. And just look at the VIIRS. So VIIRS data comes in. So you cannot directly measure electricity from it because their units are watts per centimeter square per solid angle that's measured in steradian. But you do get, I mean, there have been before VIIRS came in 2009 or 10, there's another satellite program called DMST, and there have been multiple studies that showed that yes, you can. I mean, people connected those. So it's been this school of thought has been there that yeah, it measures energy pretty well. So what we did was, instead of measuring energy, we measured the intensity of electricity usage. We set up the problem, that one huge problem we had, that our one data set was at 0.5 meter to 0.3 meter, but the VIIRS pixel was at 500 meter. So we cannot do a apple-to-apple comparison. What we instead did was we calculated proportional area of each of the settlement types inside each coarse VIIRS pixel, and set up a relationship between the radiance that the VIIRS sensor captured and the area. And as you can see, I mean, the regressions were, of course, significant, but Johannesburg had less, what do you call it, like explainability. It didn't explain all the variations in the data, but the other 2 did pretty well. But let's not get into that too much. Yeah. Mm-hmm.
Just ask a quick question. So
sure.
When you looked at the problem,
mm-hmm.
did you survey all of the existing platforms? Yeah,
mm-hmm.
I know, and sensors on those platforms, because a lot of the satellites make nighttime passes,
mm-hmm.
right? And were any of those useful? Because I dabbled using the Aster nighttime passover using infrared to look at.
Yeah, I mean, it's a good question. First of all, a lot of satellite makes nighttime passes, but they don't take any images because. But Aster, I'm not quite sure Aster fits this purpose. And we, in science, I mean, if I do first of all, I have never tested out Aster other than using their GDAM, the global DAM data. But I know they have a suite of sensors on those satellites. But the thing is, then I have to first write another paper to actually prove that Aster captures energy well, right? So and that's the problem with science, that okay, you have to refer something, otherwise I have to first make that and then refer back. And this is pretty well established, this stream of data. And DMSP was a United States Air Force program that just that you know about it, right? So basically, if you look at the regression coefficients for all this, so for Andola, in Zambia, we basically see the affluent classes. We see that the highest impact on those. In Sana, and this is something we found out because we're working with some other people who are working also with forced displacement at that point of time. So Sana was going through this. The data was around like 15 to 17. That was a time when the data sets were captured. And Sana was going through the conflict that was going in Yemen. A lot of people were living in those, those displacement, I don't know what you call, like camps and basically informal settlements. And if that is kind of like picked out by if you look at class 1, the regression coefficient around it, it's like high association with that, followed by, of course, the downtown and their commercial or industrial entities. And when it comes to Johannesburg, it's a big city, it's a commercial area, and makes sense that most of the energy would be taken up by their commercial establishments. So to summarize, and this was basically a proof of concept. This was never been done before. I was, as a PhD student, right, so I was tasked to do it. So we found a good case study, and we use a hybrid data set, hybrid approach to actually go beyond so one of the problem with VIIRS is that the coarse spatial resolution. And, but we actually were able to get insight beyond that. And this patterns, if it's used elsewhere, you can at least say where you're using more energy and try to build capacity. So that was a test case for us. So that's it. And I have some, these are the slides that I used during the hackathon. These are the useful links, and this has some planetary data sets as well, if anyone wants to use them, for sure. And also like in all the Python geospatial libraries, R packages. So yeah, so that's all I have to offer right now. But if anyone wants to ask questions or get in touch with me later, those are my contacts. And thank you again so much for listening and giving me this opportunity to talk.
Thank you.
Thank you so much, Pranab. That was really great.
Well, any questions?
Yeah.
Anyone have any
anyone
particular questions?
I had not about his talk, but about space apps in general. Actually, a whole bunch. And basically what it is I kind of compiled a list. So I've been to a number of those and to a lot of other hackathons, and it isn't that they require any answer at the time. They're kind of rhetorical questions, but might lead us down the road as we think about it to make a more enjoyable session for the the people coming to it. Is there anyone interested? I don't know what your timing constraints are. Should I take 3 or 5 minutes to roll through them?
Let's stick a pin in that for right now, Michael.
Okay.
Are there any questions for Pranab from anyone before we go into more stuff? Just want to make sure we have that covered.
I guess one question that I had was, Pranab, have you worked with commercial data sets, commercial space-based data sets? And do you find, what do you find are some of the differences between working with publicly available versus commercially available?
Great question. So yeah, the EO dataset that I told you about, those were from Digital Globe, but since I was at Oak Ridge National Lab, it's a government entity, they have like a data sharing agreement. So we could just go into their portal and just get the data. And great that, yes, there is a difference. commercial data sets are, at least with the digital globe data that I used, where they had done all the corrections and everything for you, and it's like ready to use. But what happens with the publicly available free data sets, not as much with NASA though, because NASA gives you this L1, L2, L3 sometimes. That basically means what level of pre-processing has been done. Sometimes, so publicly available data sometimes give you more flexibility because some people really want to work on the atmospheric correction part, so they can go and get an uncorrected data. People like me who really don't want to deal with that much, I can take a data that has been, taken care of with all those anomalies and top of the atmospheric correction, all that are done. So yeah, but I think I'm not sure whether commercial data set providers will give you that, but I think it's available. So that's one of the readily you can just get it off the shelf and start using with publicly available data. You need to read a little bit more because they're kind of trying to cater to a bigger crowd. So you just have to read through what it is and if you need to do anything. Like any pre-processing need to be done or not, need to be a little bit more careful.
Cool. Anyone else?
It was an interesting question, Michael, with the commercial data sets, because I work mostly in fields with public data where no commercial application is existing yet. So there is no commercial application available yet in those data sets available in the public science world. So far, at least where I worked on.
And what kind of projects do you work on, Holger?
I have websites online since 20 years showing Mars data from starting with Viking Lander, Pathfinder, Mars Exploration Rover, and now the current Perseverance rover, where you can see the daily delivered images in color.
Yeah, I'm familiar with Holger's work. He does a lot of color correction type of color calibration. So I remember he had a really great conference display years ago that was the true color on Mars, like what you would see with your eyes on the surface from some of the rover missions.
Now that was the original intention to show, because it was difficult in the beginning, 20 years ago, to access the color images directly. Black and white or grayscale images were published. And that was one motivation to show it to the public, to get more interested into space. And of course, I'm always interested to find some business opportunity, but I haven't found it yet. That's,
Very cool. Okay. So maybe I can bring my screen up again. Give me just a second, make this work. What we wanted to do was kind of break things down a little bit into smaller groups so that we can connect and chat with each other and mix and mingle, which would be easier if we were all in a room together. But James has the talent to toss us into individual rooms. A few of us at a time. We'll take maybe about 15 minutes to kind of hang out, chat, and then we'll come back out and James will mix it up again and throw us all together in a different configuration for another 15. And some of the things that, are kind of like starter questions, things that I'm interested in learning about you all is, what's your background and what interests you about hacking with space data? I know some of you have been to space apps, and maybe there's things that you want to learn more about the hackathon, learn about space data. Coming to this forum, who are the kinds of people that you'd want to connect with? That both helps us understand, the community as well as speakers that we might want to attract, and who would those speakers and what would those topics that would be the most interesting to you that we could plan for. Would you like to do a show and tell if you have a project? Is there a project that you want to do that you're looking to connect people into? These are all things to discuss, things that I'm interested in, and hopefully you're all interested in as well. And I'll let James take us away.
Yeah, so again, we're going to do 2 different networking sessions, each 15 minutes long. I'm going to put people in roughly groups of 5 to 6. There'll be 3 groups. Yeah, so there's the questions there. Probably the first thing everyone could do is just spend a minute or 2 introducing themselves to each other. And then it'll just kind of evolve into whatever you guys want to talk about on this list. And then Michael, Patrick, maybe for the second round, we can go over the questions you had. That could be a good starter for the second round. So with that, I'm going to go ahead and put everyone in their rooms, and I'll give you a 1-minute warning when we're almost up, but it'll be 15 minutes, and enjoy.
Thanks.
Welcome back, everybody.
James, do you feel like the puppet master?
This is old hat at this point. I've ran a
Controlling the world with your dashboard.
yeah. This is nothing. I mean, I had 10,000 people at the Mars Society conference. I could do 20 people, no problem.
What's your algorithm for randomizing it and making sure that you don't create the same group accidentally twice?
I have a little spreadsheet going.
Okay. I was expecting you to be using R or Statistica or something, and here it's only Excel.
There's plenty of functions in Excel, so.
Yeah, I know.
Sorry, I'm on mute. Excel runs the world, and like not enough people like realize it, but there's so much in Excel, and it's scary. It's very scary.
Well said. Imagine having them create Excel from nothing. How long that would take. Okay, everyone. Well, I hope that was fun. Any takeaways folks would like to throw out that they particularly enjoyed with those breakout sessions? Anything new that you learned that was really interesting?
Completely new.
Well, mine, we had a nice talk about data science and how folks are training for that. And I shared a story about someone I knew at Microsoft that was a data scientist a few years ago that really did not have a ton of direction from management on what to work on. So he took a stab at building a recommendation engine, and then they couldn't figure out how to use it in the product. And so he left, and he was a really good data scientist, but it's like a square peg in a round hole there. So, and he told me about a year afterward when we were having coffee that his first month when he wasn't getting a ton of direction should have been a warning sign to him that, you know, maybe he should go figure out the business a little bit more before he starts coding. So any other takeaways you guys had?
It's always interesting to hear that mostly it starts with fiction, with science fiction. That is for many the motivator, also for me.
I wish we talked about that in our breakout session, actually. That would have been fun.
Okay, so we're going to move into the next one now. And I think, Michael, Patrick, you had some questions you like to ask people for breakout rooms. You're on mute, Michael.
Sure. So as I mentioned, I've been to a couple of the NASA hackathons and many other ones in general. And usually I'm the only geospatial person in the room. So I spend a lot of time going to other groups and helping them find data. And one overall impression, so we have a bunch of people arriving for the event at a spectrum of different educations, ages, tech skills, etc. is, do we have any historical knowledge of what that breakout look, or what that breakdown looks like. Is it mostly coding people? Is it mostly hacking, experienced programmers or high school students or whatever? And then, because without knowing that to a certain extent, maybe a survey could be sent out, to our local community to, parse out some of those things so that we could derive a better type of event. And the one thing I always fight, and if anybody has a good answer to this, and this is mostly for people that are new to NASA data and spatial data in general, is I'm always fighting Hollywood. Is, people have in their mind that it's this all-seeing eye in space that's pointed down to where you are, like, the Enemy of the State movie, that can zoom in on the car license plate or whatever. So it isn't even just finding the particular type of data. It's generally around, what do these satellites do and what can you get from them? And, just basically the return rate sometimes over like Landsat's 2 weeks, and some satellites are twice a day. And the other big barrier is there's such a wealth of data. And if I were king of NASA or whatever, I want a big graph, right? Which doesn't show the data. It shows the data, but what it's been used for, right? Oh, some hydrologists use this, or farmers use this, or whatever, roles which are readily recognizable, so that when somebody shows up new to the hackathon, this is a farming thing. Here's some places where data, was a top 10 list or whatever, so they could get jump started peering into that vast catalog. And similarly, the tools, there's, in my mind, if there could be a simple leaflet implementation that somebody who is not a new programmer could just put the URLs into the layer list, cut and paste, and now they have a web thing with different transparencies, which is overlaying some NASA data set. That would probably solve 90% of what people kind of want to do. They don't necessarily, and again, I'm speaking about the newcomer, is they don't necessarily want to do machine learning on it or whatever. And having an early success with data is really, really important. When I tutor people, the first thing in something complicated is setting the bar low so that they feel power is, to me, and it's subset of the tools issue. It ends up falling over the edge into GIS and all the projection and all of that sort of stuff. And if there's a way to like pick out a web-based platform, and there's like Cardo is out there and some of those where people could use that web service to put their data up there and get it on some sort of web presence. Similarly, a low bar for implementation. The bit about the processing levels, somebody mentioned in our room, the level 1, 2, but there's rarely are mentioned the derivative data sets, like the DLR has some awesome ones for urban extents, CDAC was mentioned, etc. Is you don't need to work from the raw satellite data. There's awesome stuff. And the other issue is giving somebody new a way to feel out when you're dealing with some of this data. It is gigabytes, and processing it is problematic in a 2-day event. So getting a realistic expectation of what you might be able to accomplish, or the tool to clip that data down into a very small area of interest, a cook cheat sheet or something, how you can knock it down into something that's manageable. The other great difficulty is the notion of scale in the world and how that relates to the problem, but also resolution. Everybody seems to think you need to have, 1 centimeter visible light photography to get what you want done. And there's lots of data that seems to be very coarse, but I think our presenter tonight showed that you can get amazing results out of very coarse data. And that kind of segues into the get past visible light. Visible light is actually, your typical photograph is actually a lot harder thing to handle, and most people aren't aware of all that radar imagery and infrared imagery and other things which can make their problem, literally stand out like a flare, on the background. So the other difficulty I have, watching newcomers interact with the various challenges is there. What might be useful to do this to get them jump started into their particular project, right? So necessarily they want innovation, etc., so they keep them large and kind of open, but just coming up with a doable problem based on that challenge is sometimes a barrier, and which led to I don't know if we could possibly, just running this up, brainstorming here, do we have pre-events like a data scavenger hunt, right? Like in the community is, okay, here's where did that show what on earth, here's an image, where do you think it came from? Or here's a problem, here's the data catalog, what do you think might be useful, etc., and give out some attention or accolades or whatever of who responds to it what, to get people into the loop and get them interacting with one another. I am nothing by myself. I rely on a whole bunch of other people in the world. That universe of data is just too large. Something like GeoGuessr or Where's Waldo or hide and seek or whatever prior to the event that would engage people and maybe along the way develop some skills. So those are just some general things that are kind of on the top of my head.
Okay, so I heard these are discussion topics potentially for folks in this next series of breakout rooms. I heard popular data sets, tools, project ideas, ways to visualize data, tips for beginners and best practices of processing data, and then working with data in terms of the image resolution and visible light, and then finally jumpstart ideas and pre-events. Okay, that was a lot, but here's some ideas to talk about.
But if I could summarize it, how do we get the beginner, the non-coder, the past that stuff as rapidly as possible so that they have an enjoyable experience? My particular ones are not necessarily the most important or whatever. And if you have encountered your own, I would love to hear those too.
Okay.
Happy to provide what a newbie would need to know as well. Very little information over here.
Yeah, no, we definitely want to help that problem of how does someone get started with this area, and we'll be helping to provide some resources over time for that. Go ahead, Michael.
And that's why, Michael, we're recruiting you here and now for the Space Apps organizing team.
You're drafted. Okay, so 15 minutes, everyone. I'm going to start the breakout rooms now. Same drill as before. You might want to spend a minute or two introducing yourselves to each other. You'll be with a different group of people from last time, and I'll give you the 1 minute warning when we're ready to end. Alrighty, enjoy.
Thanks.
All right. Welcome back, everybody. So who would like to share how this round went?
Well, in my room, we were just talking about Kaggle. Aaron was posting in there, and it seems like a pretty neat way to get involved with some data sets and challenges around working with them. And maybe a topic that we want to explore more in a future session, and definitely would allow us to connect with a do, right? Like a bunch of us just go off and do one of these Kaggle challenges.
What is Kaggle? Website, huh?
I think it's in the chat. Yeah, I just
Oh,
clicked
yeah.
on it myself.
Aaron, describe Kaggle.
Voluntold.
Okay. So Kaggle is a competition website that hosts data sets for people to kind of jam on. It can range anywhere from like fraud data to potentially like space data. I haven't done too much searching in it, but it's pretty wide open. Like anyone can just download the data sets. The competitions, if you're more serious about it, target, you know, specific values. So like who has the best R squared, you know, you win the prize. It is essentially you get a test data set, you get a train data set, and then like a kind of optimization framework. Like you're essentially giving them a model to run, and in the end, they will take your model, run it against the holdout data set, and judge you based on like the F1 score, like whole least square, I don't know. And whoever wins, you know, there's usually a monetary prize or some sort of recognition, but it's a pretty fun place to kind of test the water. I did one, it was how to predict whether or not someone would download an app based on like the clicks of like a cell phone. So based on like their IP and like a few other features, you know, how likely would they download your app if they spent some time on your site? So that was a pretty fun one. But outside of that, like kind of sky's the limit on it. So pretty fun. You can also do historical stuff. So once the competition is ended, they still host the notebooks and data for anyone to kind of work on and practice and kind of compare against the people who have submitted and potentially have won the competition. So you can kind of judge your skills based on that.
Yeah, I've seen similar workbooks or sketchpad online services, but that one then here, this one is also focused on competition then, yeah, that seems, that's a bit different. Yeah.
Cool.
Any other takeaways from the breakouts?
I think our group talked a little bit about, you know, the issues that Michael Patrick was talking about, like, you know, basics. And so I strongly requested them to talk to you and Mike Doyle to kind of figure out how to address those. But I think it'll be nice, like, you know, if people come in with a little, you know, more formed idea on the basics so that they can get started faster.
Mm-hmm.
Yeah, I think our pre-events are going to be really important. And I think some of the folks who are here who love space data and know something about it and can provide mentorship and help guide the folks who are just getting into it will be part of that success.
Yeah, I'm interested in setting up a resource wiki to collect all of the popular data sets that people like to use that are space related with these types of projects. We could have an area for beginners as well that has the tool sets and the trainings that are free or cheap to learn data science and all the technologies we work with. So I'd like to work on that.
So Lauren, do you want to, or are you moving on to the other group?
What do you mean?
Oh, the results of our breakout.
Oh, go for it. You go ahead.
You're the customer.
we talked about also like what might be useful. Pre-events were definitely a huge topic. Being able to have a explanation of what is a hackathon, what is Seattle Apps Challenge, the Seattle Space Apps Challenge, how can someone who's not tech background contribute and participate? Because that's definitely something that I, as a non-tech background person, went, maybe I won't participate in 2019, as Mike Doyle knows. But there was a lot of really great suggestions. And now I'm very, like, I really want a mentor program now, a lot.
Yeah. So Lauren is also on the Space Apps, the Space Apps Seattle organizing team. And oh, by the way, our really cool logo with the Saturn and the data rings, she did that. It's really awesome.
Thanks,
so
Mike.
Shout out to Lauren for that.
So one of the, again, is the people that aren't tech oriented. And like my first NASA Space Apps is, I think I got a global nominee or whatever, because I wrote an essay, right? And people do art and people do those. And that's invisible as you look at the presentation right now. So can we have a gallery of the non-tech projects, the things that people made, created, etc., that weren't code, to pull in those people? Oh, I can do that. Oh, that's what I do, to create that identification with the non-developer, non-technical sort of community.
Yeah, for example, last year we had a team that did a 3D printing project.
Oh, yeah, that was awesome.
They were visualizing, I think it was some terrain in Seattle, downtown Seattle, but visualizing it with a 3D physical model.
Yeah, they had a topographical model of Seattle that was accentuated so that you could, so that it popped a little bit more, and then overlaying, geodata about the area, and basically they could take whatever data set you threw at it, and you could visualize it over that, whether it was wildfire smoke or weather or socioeconomic indicators. Yeah, it's pretty cool little project. And they put it all together over the weekend of the hackathon. And I think some of the judges couldn't believe that was all done that weekend. Like, oh, they must have brought it in. It's like, nope, they started from scratch.
They couldn't believe, I remember that. They couldn't believe that they did that. And I'm like, no, I watched them working on it. So
we are almost at time. And for me, that means bedtime for my kids. So let me just share the last slide that I've got for tonight. Ooh, there we go. Okay, so what's next? Like I said, this meetup will occur the last Thursday of each month. The next one will be the 27th, followed by the 24th. We'll circulate a topic survey for both folks who are here and also not here. And I'll be looking to some folks who are interested in doing maybe a little bit of show and tell. As a reminder, the NASA Space Apps Hackathon is October. It's technically the 2nd and 3rd. That's a Saturday and Sunday, but in Seattle we kick it off on the 1st. Yeah, on the Friday, and we start forming teams. And we'll have a guest speaker, keynote speaker, and it'll be a lot of fun. We're also planning a startup weekend Techstars Startup Weekend Seattle around space data, and looking to launch that next year once this group is a little bit formed, and we've got folks going through the hackathon who want to take their knowledge of space data and marry it with entrepreneurial skills and basically do a weekend event where you come in on a Friday, you form a team, and you build a business by Sunday afternoon with a focus on space data. I've got a link down here. We'll post it out. We've got a Slack, and we'll use that as a way for folks to get together in the interim between our get-togethers, so that we can share files and links and chat and community, which I don't know. I felt pretty good about tonight. Did you guys have fun? I had fun.
Yeah.
Yeah, for me, it was the first meeting with Seattle Space Hackers. And what I was wondering, because I'm interested in potential new scientific discoveries from new data, which is currently sampled. Would that also fit into that, or is this
totally
more, are the meetings more as preparation for the yearly hackathon?
No, I don't think that this is not just about the hackathon, and I don't want Space Data Hackers to be solely about the hackathon. I think like scientific discoveries that have come out of space data is an awesome thing to highlight. You know, in my breakout session, I was fantasizing about if I got some time to work with some space data myself. The data set that I would want to work with is TESS, the the exoplanet hunter that replaced Kepler. I'd be so excited to just like go. I don't even need to find an exoplanet, maybe just a candidate. I'd be happy with that.
Yeah, that they are actively finding new exoplanets with that data set right now. So that came up on another call I was on today. So yeah, no, I don't think we're limited to anything with this meetup series. We wanted to hear from the community as to what are the interesting things that we can cover and foster with this group. So yeah, we'd love to hear your feedback.
Yeah, Holger, I'm especially interested in that too. I run into gaps and that, you know, there's only so many people in the world, and a lot of them are constrained by their research program or funding or whatever. There's lots of interesting scientific problems that need some attention.
Awesome. Thank you all for coming, and thank you so much, Pranab, for you know, kicking us off with our very first session. And
my pleasure.
Really interesting and informative. And to all of you, I am really looking forward to seeing you all again next time.
Have a great night, everybody.
Bye all.
Hi, everybody.
Good night. See you later.